Now that we know how to write equations of lines, what we're going to get into is looking at real-life data and seeing if we can come up with some lines of best fit. But before we do that, we do need to know certain vocabulary that has to go with it. So at the end of this lesson, you'll be able to use the vocabulary associated with lines of best fit. All right, first of all, what is a line of best fit? A line of best fit is a line that passes as evenly as possible through the data points that we have drawn. Right? One thing that we will be doing when we draw data points is we first of all will draw a scatter plot, and that's basically just a graph that's used to determine whether there is a linear relationship between paired data. Scatter plots can show trends or patterns in data. So we can tell, is the data forming a line or is it not? Is it forming something else? Okay, the next word that I would like you to know is something that's called correlation. And is there a linear relationship between the two variables? Okay, if there is a positive correlation, what we're going to see is something like these would be data points. And you'll notice if you look at these data points, you can very easily see that there could be kind of a line drawn between those two things. It's positive because as the x values increase, so do the y values. So it's headed in a positive direction. Okay, if we have a set of data that has negative correlation, then it's going to, the scatter plot would look something like this. Again, it might not be perfect, but we basically we see some dots that are forming a linear pattern. Okay, and this time the dots are headed in a downward direction, which means as x increases, the y values would decrease. So maybe the more time you spend on video games, the lower your test scores are going to be, or something like that. Okay, and then we also have one where there is no correlation, and no correlation might look something like when you draw the data points. Those are all the data points that look like that. And notice there's no connection. You're not seeing a pattern between those numbers. All right, one letter that we use to describe the correlation coefficient is R, and it's just a number between -1 and 1. And a linear relationship, no relationship, the R value would be 0. A positive relationship, right, and a negative correlation, remember, it would be -1. So that's the biggest values you can have. As you move this way, it gets stronger. And as you move this way, that means there's a stronger relationship. There's more of a connection. You could predict something and actually get it right. So if it gets close to -1, it's stronger, and if it's closer to 1, it's stronger. And this would be a negative correlation, and this would be a positive correlation. So the closer you see the dots together, the more stronger the relation is going to be. Right, and the last thing that we just want to note is that correlation does not necessarily mean causation. Just because they're related doesn't mean that one thing caused the other. As an example, if I was comparing somebody's shoe size and their reading level, there is definitely a correlation, because I'm sure if you drew a graph, the bigger someone's shoe size is, their reading level is usually bigger. It didn't mean that their feet growing caused them to be able to read it better. It just basically was their feet probably were growing because they're getting older, and as they're getting older, their brain's developing, and that's what's causing the reading level to go up. So we just have to be careful when we do that. And I think that's all I need to say about vocabulary. So hopefully now you're ready to dig right in and actually find equations of lines of best fit.